Hi, my name's Tim Moore. I'm a sales representative with Nidec US Motors. Today I'd like to talk to you about the upcoming Department of Energy addendum to the pump law that now includes replacement single-speed and two-speed replacement motors. When you go out to install a variable speed motor, you have several options that might occur in the field. You might be able to install your motor and use the programming on it as a standalone application. You have the ability of integrating it mechanically with old time clocks, or you have the ability of programming it with anybody's automatic controller. Specifically, I'd like to talk to you today about the 12-volt low voltage block that we have on our motor. This gives you the capability of integrating it with time clocks. The reason that that's important is the best practice of every variable speed motor is to wire it line hot. And that way, the computer on the variable speed motor doesn't turn on and off every day. When a computer reboots itself, it may not come up correctly. You may have an error with it rebooting correctly. So most manufacturers will recommend that variable speed motors are wired line hot. The computer stays on all the time while the motor can turn on and off as it is programmed. When you are working with old time clock systems and you're wiring a motor, you no longer want to wire a variable speed motor on the load side of the time clock. You'll need to move it over to the line side of the time clock. When you put your motor onto the line side of the time clock itself doesn't function as a time clock anymore. And that's okay, again, if you want to program the motor to do all of the actions of the motor on the display itself. If, however, you would like the customer to still use the toggles or be able to use the time clock with the on-off trippers, you can repurpose this time clock by adding in a fireman switch. This fireman switch is a micro switch that can be wired either high voltage or low voltage. And one of the unique features of the Neptune variable speed motor is this low voltage block. On it, there is a 12-volt output, which is very important. There are 4 inputs that give you 4 different RPMs. Input 1 is about 1,380 RPM. Input 2 is about 1,900 RPM. Input 3 is about 2,900 RPM. And input 4 is 3,450. When you add in the fireman switch, there are 2 leads that come off of it. It doesn't matter which one that you use, but you're going to need to run 2 low voltage wires off of our low voltage board. One of them will come from the 12-volt output. It will supply the energy to the fireman switch for it to work. The other lead will come back into one of my 4 inputs. In this case, I actually have it into my input number 3, which is 2,900 RPM. If someone comes out and hits the toggle switch, or the tripper comes around, the motor will go into a manual override. It will stay at that RPM for as long as there's energy to this time clock. As soon as energy is lost to the time clock, the low voltage signal is disconnected and the motor will go back into its normal operating mode or into its off position. You may only have 1 time clock. I have 2 pictured here because a lot of applications, especially with older pools, have booster pumps. And there is a second time clock to operate that booster pump. That booster pump is actually wired to the main time clock on the load side and it operates off the load side. But remember, we're no longer working off the load side, we're working on the line side. So this booster pump, this timer is no longer talking with this timer. This timer is now trying to talk with this digital timer. And there's an opportunity that those two times might come out of sync. So, the same way we added the fireman switch here, we could add one into the booster pump. And even if it's 2:30 in the morning and the booster pump says it's time to come on and this doesn't, they're out of sync, as soon as there's energy, 12 volt out, other one into our input number 4, and now you have the motor at 3450 operating in conjunction with your booster pump for as long as there's energy going to this time clock. As soon as the time clock loses its energy, the motor will come out of manual overriding back into its normal operating mode. Now, additionally, as a third piece of equipment, in many areas from the mid-Atlantic states, I would say from Dallas up to Wichita, from Las Vegas over to Charlotte, North Carolina, you might have a freeze control system. That freeze control system used to turn on your single speed motor at 3450 for as long as the thermostat said it was needed to have it on. Well, that thermostat might look something just like this. And it's already sitting there on the wall. You can utilize our low voltage block and repurpose the thermostat to work with the motor and give yourself true freeze equipment protection out of a variable speed motor. The way we do that is we'll isolate the thermostat, we'll pull the wires off of it as it exists on the wall right now, and then we will run 2 low voltage wires, one 12 volt into either one of the spades, and the other lead coming back into one of my 4 inputs. In this case, better safe than sorry, I've got this thermostat set for 3450, so we save the entire equipment. As soon as the thermostat says that it's cold enough, you now have a under $100 thermostat that has manually override and is controlling this motor. This motor will stay on for 2 days, 3 days, for just as long as it thinks that the thermostat needs to have it running. As soon as the thermostat comes up to temperature, the motor will go back into its low energy saving mode. This is the way that you can make the Neptune variable speed motor work with any older system and freeze control, and you can leave the job knowing it was just like you left the single speed motor in its place. Thank you for your time.